The Grand Tourer formula has always been simple to understand, yet brutally difficult to perfect. You need extreme high-speed performance, the endurance to cross continents, and a cabin of opulent comfort. For decades, European legacy automakers have owned this benchmark. If you wanted the pinnacle of automotive engineering, you looked to Italy, Germany, or Britain. But the shift to electric power introduced a massive problem. To get that required continental range, you need a huge battery pack, which pushes modern luxury EVs dangerously close to the 3-ton mark. In the physics of vehicle dynamics, weight is the enemy. It typically destroys the very things that make a Grand Tourer so special: nimble cornering, precise handling, and reliable braking. Building an electric GT requires more than a high-capacity battery. It requires replacing passive mechanical parts with high-speed digital control over the vehicle's massive momentum. Enter the Denza Z9 GT. This is a new challenger from BYD's luxury division, and it is explicitly designed to rewrite the rules of the high-performance market. Designed by former Audi design chief Wolfgang Egger, it adopts a sweeping shooting brake profile. The low-slung, aerodynamic front fascia and aggressive headlights are built to cut through the air with minimal resistance. BYD is using this vehicle as a technological manifesto. They packed it with nearly 1,000 horsepower and a suite of bleeding-edge hardware to take on the European giants on their own turf. The goal here is clear. They want to prove that the ultimate expression of the Grand Tourer is no longer an exclusively European domain. Inside, the Z9 GT operates like a mobile executive lounge. The rear seating is massive, sitting beneath a sweeping 2.1 square meter panoramic glass roof that bathes the cabin in natural light. Denza even integrated 2 independent temperature control cabinets. The rear features a 10-liter cooler, specifically sized to hold 2 bottles of champagne or 4 bottles of wine. But a Grand Tourer still has to tour. You need to be able to cover vast distances without constantly scanning the horizon for a charging station. To solve this, buyers can choose between 2 powertrains. There is a 100 kilowatt-hour fully electric version that delivers pure, violent acceleration and a sub-3.5-second sprint to 62 miles per hour. Or there is a plug-in hybrid model using a 2-liter turbocharged engine to provide an anxiety-free range of 1,100 kilometers. By offering both extreme performance and massive range, the Z9 GT solves the primary anxieties of electric travel while pushing executive cabin luxury to its absolute limits. All of that luxury comes at a cost, weighing in at nearly 2.9 tons. How exactly do you make an executive lounge that heavy drive like a lightweight sports car? The answer lies in the hardware underneath. BYD developed a new architecture known as the E3, or San Fang, technology platform. This schematic shows how power is distributed: 1 drive motor on the front axle and 2 independent motors on the rear. Each rear wheel also has a dedicated steering mechanism, allowing them to independently steer up to 20 degrees in either direction. Decoupling the rear wheels this way, giving them their own separate power and their own steering angle, creates a completely new set of rules for vehicular control. This allows for maneuvers that look almost unnatural. Take the crab walk. All 4 wheels angle uniformly in the same direction, allowing the car to slide diagonally out of impossibly tight parallel spaces. There is also the easy 3-way parking feature. A driver can pull nose first into a diagonal spot, and the rear wheels will automatically swing the back end of the car directly into place. On a narrow 2-lane road, the system can perform a compass U-turn. By locking the front wheels and sweeping the rear wheels outward, this massive car rotates around its own front axle, effectively turning on a dime. This software-defined wheel control gives a 3-ton car the turning radius of a compact hatchback, allowing it to navigate narrow streets that would otherwise be impassable for a car of this size. But parking tricks are just the beginning. The real value of this independent wheel control becomes apparent at high speeds, in life-or-death survival scenarios. Consider a front tire blowout at 140 kilometers per hour, typically a catastrophic event. Because the motors operate independently, the system detects the drag and compensates with the remaining wheels, keeping the car stable and straight. Or picture a split traction scenario, where one side of the car hits deep water and the other remains on dry tarmac. The E3 platform calculates the individual slip on each wheel in milliseconds, allowing the driver to safely maintain a speed of 60 kilometers per hour. We often measure luxury in the softness of the leather or the temperature of the champagne cooler. But at high speeds, the ultimate expression of luxury is the active safety provided by instantaneous computational physics. The Denza Z9 GT achieves a rare overlap. It delivers sub-3-second acceleration, a remarkably opulent putative cabin, and active safety systems that were technologically impossible a decade ago. And it brings this package to the market at a fraction of the cost of the legacy European models it competes against. To reach this level of performance in the past, you needed a massive, mechanically complex engine. Today, you need extreme, software-defined control over every individual wheel. As Denza launches globally, hosting their debut at the Paris Opera House, the legacy titans find themselves facing a new benchmark. The Grand Tourer has been re-engineered, shifting the focus from mechanical prestige to computational precision.